Well, this presentation is on a topic called reducing radicals. And before I introduce the topic per se, I want to say something about mathematicians and how mathematicians kind of get a bum rap. Well, a lot of people say that mathematicians, we could think of them as math guys, as it were. And let's just write down math guy over here just to stand for your average math guy. A lot of people will say that math guys don't have much style. They say that we're kind of stylistically impaired, you might say. You could think of it kind of like this symbol from Europe. And, well, there's some truth in that. In fact, there's probably a lot of truth in that. One thing to keep in mind is that math people, while they may not care a whole lot about how they look and whether or not they're wearing the latest hair design, they do care about the style of their mathematical terms. They care about that an awful lot. And actually, the topic of reducing radicals has to do with that. There are two different forms of an answer, and one is considered very gauche and ugly, and the other is considered beautiful and fine. And in this lesson, I'm going to teach you about the difference so that you can make your answers beautiful and fine. Now, you want to know what it means to reduce a radical in the very first place. So let's take that very idea. Let's suppose that we want to reduce or simplify a radical such as the square root of 8. And what would that entail? What would that require us to do? Well, one thing to know is that there's a basic rule that governs or tells us what we're supposed to do when we try to reduce this radical. And that basic fundamental rule, I'm going to put that over here, it's a rad rule. It's a rule about radicals. And what the rad rule says, basically, is that if you've got the square root of two terms that are multiplying each other, like a times b, they're both under the radical, and there's just a dot of multiplication between them, you can actually change the form to two different radicals multiplying each other with those same factors underneath. So we're going to use that idea to simplify the square root of 8. And you might be wondering how? How can we use that rule here? Well, the idea actually goes back to the concept of what's called a perfect square, because what we're trying to do is figure out if there's a perfect square that divides evenly into 8. So to understand that, let's first think about what we mean by a perfect square. Let's make a little table. We've got numbers over here, and we've got perfect squares over here on this side. And what is this all about? Well, let's say a number is the number 1. What's the perfect square of 1? That would just be 1 times 1, which is 1. So the perfect square of 1 is 1. How about 2? Well, what's 2 squared? What's 2 times 2? 2 times 2 is 4. So the perfect square of 2 is 4. And similarly, we could ask about 3. What is 3 squared? 3 squared is 3 times 3, which is 9. So there you have it. There are some of the earliest perfect squares, 1, 4, and 9. Now, when we try to reduce radicals, the perfect square of 1 isn't really helpful, but the others can be, and that's what we're going to use right now, in fact. So what we do is we ask ourselves, okay, looking at 4 and 9, does either of those numbers divide evenly into 8? And, of course, if you think about that for a minute, you know that 9, of course, doesn't go into 8. It's too large, but 4 does go into 8, and it goes in twice. So we can change this radical, first of all, to the square root of 4 times 2. Since 4 times 2 is another way of saying 8. And what do we do next? Well, here's where we use our radical rule. We've got the square root of two numbers under the radical. They're multiplying each other. Just as we did here, we split them apart. We could split these two apart, and we get 2 radicals for the price of 1. Square root of 4 times square root of 2. Okay, so far so good. But where are we going? You might be wondering, how's this helping? Well, here's how. The square root of 4, well, 4, because it's a perfect square, also has a square root, which is a nice number. The square root of 4 is simply 2. So since the square root of 4 is 2, we can substitute 2 for the square root of 4. So now we've got 2 times square root of 2. Okay? Now we're really almost there. There's only one last thing to do. And this again has to do with style and math. So I'm going to write it over here. You know that when you're working with numbers and variables, you can take something like 2 times a and clean it up a little, like giving it a little haircut and simplify things, just call it 2a. Get rid of that ugly little dot there. We don't need that dot. In the same way, when we've got 2 times rad 2, we actually don't need that little dot of multiplication right there. We can get rid of it and make things look cleaner, neater, tidier, and that's the form that we want to put it in, just 2 rad 2. Now at this point, guess what? We've accomplished our goal, because this answer here that I'm circling in blue, 2 root 2, is definitely considered much more beautiful, much more stylish, much nicer than the square root of 8. And one of the reasons why is that we've reduced the size of the numbers involved. 8's a reasonably big number as far as single-digit numbers go. 2 and root 2 are both very small numbers. They're easier to think about. That's why that is considered reduced. And if you take a moment to think about this, you'll see that it's not very different from something you did back in elementary school. Back then, you'd have something like a fraction like 6/8, and your teacher would say, well, if there's a number that goes into both 6 and 8, you have to divide them both by that number. What would that be? 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So we learned from that the fraction 3/4 is considered a simplified version of the fraction 6/8 because the numbers involved are smaller. So once again, using our principles of style, using our rules, we take a term that's kind of large, clumsy, and boil it down to something slick, smooth, and tidy. And that's part of how mathematicians show their style. And you can too. We're going to practice this a little bit in the next lesson, and you'll get your chance to try your hand at reducing radicals as well.